The Roland R-8 was released in 1989. It's a digital ROM playback drum machine. However, it had two distinct differentiators. First, its system architecture is very similar to the Roland D50, which goes to its high quality of sound. Second, it was the first drum machine to attempt to emulate how a human plays drums. It adds in timing errors, pitch variation, and sample substitution in order to sound more like a real drummer. The Roland R-8 MKII was the second version. Released in 1992, it was almost a perfect superset of the original R-8, as it added many of the expansion cards internally. I've always wanted one of these, and when the opportunity came up on eBay to buy one, I jumped at the chance. This one was missing the power supply, however. We'll get to that later. So here's the unit, cleaned up as you can see, a little bit better than the eBay ad. Some of the outputs, and especially this proprietary power supply with ground, +10 and -10, to which I am missing. Here you can see it a little bit closer. You can see in the bottom there's still a bit of glue. I wasn't able to get that off yet. And it's missing all of its rubber feet. So let's take it apart. As we remove the case, you'll see we have the jack board in the lower left. That's the brown one. And then the main board, which is in green, which we're going to go into detail in a little bit. To get access to the main board, we have to remove all the screws and ribbon cables and wires connecting the jack board to the main board. So we'll do that now. Okay, so here's the main board on the workbench. So let's talk a little bit about how the R-8 works. We'll start with the main or system CPU. It's 8-bit with a 1 megabyte address space. It's an MCU in this case because it contains a small ROM and RAM. However, not enough for this application, so Roland has added an external ROM to hold the firmware and SRAM for runtime variables. It's connected to this gate array, which primarily decodes addresses. Note the external RAM card sits on this address and data bus as well, since it's used to hold and save kit and pattern data. Not sample data, however. This next area is referred to as the sound generator. This in itself is another computer entirely. Recall in 1988, it was much too expensive to run the application processor at the speed at which samples need to be clocked out to the digital to analog converter. Also recall that our system MCU is only 8-bit, and these are 16-bit samples. The common solution to this problem in this time period was to design a hardware state machine that can generate addresses, read samples, and feed them to a digital to analog converter. This is how nearly all digital sampling instruments were designed in the 1980s. The emulator 1 and 2 did this with discrete logic. By the late 80s, when the R-8 was designed, this could be done more economically with ASICs, like this one. This sound generator then runs asynchronously to the system MCU. The system MCU simply tells this ASIC what sample to play and at what pitch via shared ports in the system MCU's address space. The digital to analog converter, or DAC, is a Burr Brown PCM54HP. This is a very high quality 16-bit DAC and the same used in the Roland D50, which was designed around the same time period. This was a very expensive part back then, so to save money but still have multiple analog outputs, this single DAC is cycled through a sample per output, with the output voltage buffered by analog circuitry. Back to the missing power supply on this unit. The R-8 and R-8 MKII both need +10 and -10. And this is a proprietary connector, so I can't even build a cable from scratch. However, there exist economical power supplies that are small that produce ±12, which is pretty close to what the R-8 needs. Looking at the schematic for the jack board, however, the +10, -10 is only really used by the muting circuit for the output so they don't pop when the system turns on. The entire system runs on +5, -5. So I could actually just feed +5, -5 in and bypass those regulators, but I think just to keep this solution simple, I'm going to feed +12, -12 in and let the regulators do their job. This Meanwhile PD25 is actually small enough to fit in the back right corner of the R8. Then I can make this R8 not only function again, but work on every voltage all around the world, which would be pretty cool. First, I'm going to design a bracket using Fusion 360, which I can screw the power supply onto and then screw the bracket into the R8. Since we're dealing with high voltages here, I want to make sure that this switching power supply is secure. Here I have the PD25 wired up using a modular connector to feed the +12, -12 ground in. Now, I need to remove the proprietary connector so I can put in a high voltage one. So I'm going to desolder this proprietary connector. It only has 3 connections to make room. I won't be soldering the new connector into this board, of course. I still want to feed the +12, -12 in here, however, because then I can use the power switch to turn the unit on and off. A better solution, of course, would be to switch the AC power going into the modular power supply, but let's try this first. I'd like to fit the high voltage power port in the same opening in the case as the proprietary port, as you can see here. I've already taken it out. So, looking at the 2 sizes, I've got one with flanges here and one without. I think the one with flanges will work better. So now assembly. So I have to solder the high voltage wires onto the high voltage port and feed the port into the back of the unit. Let's see how it fits. Almost like it was meant to be. So I'll mark some holes in the chassis where I can put a couple of small nuts and bolts. I've got the PD25 power supply mounted on that custom mount and screwed into the chassis. All the wires are just about in place, so I should be ready to test this and see if it works. All right, so let's plug it in. The moment of truth. Does it work, or will we have smoke? Goes in, plug it into the wall. Fingers crossed. Will it work? I think it will. And it works! Roland R-8 human field rhythm. I wonder when the last time this unit was powered up.